Spacecraft charging, SC. Spacecraft charging, SC, is the buildup of charge on spacecraft surfaces or in the spacecraft interior. SC causes variations in the electrostatic potential of a spacecraft surface with respect to the surrounding plasma environment, and potential variations in different portions of the spacecraft. The major natural space environments which contribute to SC include the thermal plasma environment, high-energy electrons, solar radiation and magnetic fields. Although SC has many effects, electrostatic discharges appear to be the most dangerous of all. Electrostatic discharges can cause structural damage, degradation of spacecraft components and operational anomalies due to damages to electronics. SC can be categorized into two: surface charging, which include differential charging, and internal dielectric charging. Surface charging is caused by low-energy plasma, 100 keV, which penetrate into the spacecraft equipment where they deposit charge inside insulating materials. Internal discharge is more damaging since it occurs within dielectric materials and well-insulated conductors, which are in close proximity to sensitive electronic circuitry. Based on data from the Combined Release and Radiation Effects Satellite, CRR, obtained at GEO, most environmentally induced spacecraft anomalies result from deep dielectric charging and the resulting discharge pulses, and not from surface insulator charging or single event upsets. Single event effects, SES. Single event effects, SES, are individual events which occur when a single incident ionizing particle deposits enough energy to cause an effect in a device. SES are generally caused by two space radiation sources, high-energy protons, and cosmic rays. Single event phenomenon can be classified into four: I. Single event upset, SCU, 2. Single event latch up, SEL, 3. Single event burnout, SEB, and 4. Single event gate rupture, SEGR. SEU is a change of state caused by ions or electromagnetic radiation striking a sensitive node in a microelectronic device, such as in a microprocessor, semiconductor memory, or power transistors. The state change is a result of the free charge created by ionization in or close to an important node of a logic element, for example, memory bit. The error in device output or operation caused as a result of the strike is called a soft error. The mechanisms for heavy ion and proton SEU in devices, for example, dynamic random access memories, DRAM, and galactic cosmic ray energy deposition in devices are depicted in. SEU can cause a reset or rewriting in normal device such as in analog, digital, or optical components, and may also have effects in surrounding interface circuitry. A severe SEU is the single event functional interrupt, SEFI, in which an SEU in the device's control circuitry places the device into a test mode, halt, or undefined state. The SEFI halts normal operations, and requires a power reset to recover. A. Mechanisms for heavy ion and proton SEU. B. Schematic showing how GCR deposit energy in an electronic device, and C. Upset mechanism for dynamic random access memories, DRAMs, from Ref. SEL is used in integrated circuits, ICs, to describe a particular type of short circuit which can occur in an improperly designed circuit. It is the generation of a low-impedance path between the power supply rails of a MOSFET circuit that can trigger a parasitic structure which disrupts proper functioning of the part and possibly even leading to its destruction due to overcurrent. SELs are hard errors, and can cause permanent damage. It can result in a high operating current, above device specifications, drag down the bus voltage, or damage the power supply. Latch-up can be caused by protons in very sensitive devices. And SEL is corrected or cleared by a power off on reset or power strobing of the device. SEL is strongly temperature dependent. If power is not removed quickly, catastrophic failure may occur due to excessive heating or metallization or bond wire failure. SEB is a condition caused by high current state in a power transistor. It is a highly localized phenomenon, and includes burnout of the drain source in power MOSFETs and BJTs, gate rupture, frozen bits, and noise in charged coupled devices, CCDs. SEGR is the formation of a conducting path or localized dielectric breakdown in the gate oxide resulting in a destructive burnout. It occurs at MOSFETs, BJTs, and CMOS. Solar flare particle events pose the most extreme SEU producing environment, especially for spacecraft in interplanetary space. Experiments aboard CRUS showed a significant increase during a solar flare. Based on CRUS data, most saves come from high-energy protons through nuclear interactions and not through direct deposition from either protons or cosmic rays. For LEO satellites, trapped protons, especially in the SELA, are the greatest sea threat.